Permission systems have a golden rule. When an allow and a deny collide, deny wins, always. It lets you grant access broadly, then carve out precise exceptions that can never be accidentally granted back. Simple enough inside one process. But we're distributed now, and that deny list travels across the network, inside a token, and a token is just data. So here's the unsettling question. What stops something in the middle from quietly deleting the deny list, turning a no into a yes? Let's defend the contract. First, the rule itself, because it's everywhere. Deny overrides allow. You grant permissions broadly. Say, everyone on the team can edit projects, and then you deny precisely, except this one contractor. When those two rules collide on that contractor, the deny wins. Why design it this way? Because it's fail-safe. A deliberate exception, a revocation, a suspension can never be quietly undone by some other rule that grants access. Firewalls do this. File systems do this. Every cloud's permission system does this. Conflicts resolve deny first. It's how you make no actually mean no. Now the distributed problem. That deny list has to travel to each service, so it rides inside the internal token as a forbidden permissions claim. But tokens pass through proxies, meshes, middleware, a lot of hands. Imagine one of them, buggy or malicious, simply drops that forbidden permissions claim on the way through. The deny list is just gone. And now the actor, who was explicitly denied something, silently gets it. That's a privilege escalation, and it's completely invisible unless you designed for it. So how do we defend it? 3 layers. First, a sentinel claim. A little version marker the gateway always stamps, proving this token came from a gateway that speaks our contract. Second, and this is the clever part, the gateway always emits a count of the permissions and the denied permissions. Even when the deny list is empty, it emits the count 0. So the deny list is absent because someone stripped it, becomes distinguishable from the deny list, is legitimately empty. If the count says 3 denies but the consumer sees none, it fails. Third, a strict shape check rejects claims that look mangled, comma-joined values, or JSON stuffed into one field, the fingerprint of a broken gateway. Absent, tampered, or mangled, all caught. In Trellis, the consumer opts into all of this by hydrating the actor from the internal token. Strict claim shape is on by default, and the provider automatically enforces the rest on every request. The sentinel version must be present and correct, and the count of denied permissions the token claims must exactly equal the number the consumer actually sees. Any mismatch, a missing sentinel, a count that doesn't add up, a mangled claim, and it doesn't guess. It returns no actor at all, which the pipeline turns into a flat 401. It fails closed. And that fail-closed posture is the whole point. When any part of the contract is violated, the provider does not hand back a best-guess actor with some of the claims. It returns nothing, no actor, which the pipeline maps straight to a 401 unauthorized. This matters because the alternative, reconstructing a partial identity and hoping, is exactly how privilege escalations happen. Here, the attack backfires. A proxy that strips the deny set to escalate a user doesn't grant them anything. It breaks the count, fails the check, and locks that request out entirely. The tamper becomes a denial, not an escalation. That's a contract that defends itself. So, deny overrides allow. The most important rule in any permission system, and in a distributed one, you have to defend it. A sentinel proves the token's origin. Always-emitted counts make a stripped deny list impossible to disguise as an empty one, and a strict shape check catches mangled claims. Any violation fails close to a 401. The permission contract defends itself. Next time, we tackle a harder authorization question. What if the thing you need to check ownership against lives in another service entirely? Authorizing across hops. Subscribe, and I'll see you there.